In this week, we are going to talk about solving linear inequalities and absolute value inequalities. So we first need to talk about one of the ways that we can write our answers when we are dealing with inequalities. So that way of writing our answers is called interval notation. Okay. So interval notation, okay, is the way of writing our answers like this. Okay, so this is a way of describing where our possible solutions exist. Okay, so the way we can think about these problems is they're all very similar. Okay, there's just slight differences to each of them. Okay, so for each of these, notice we have x's between -2 and 7. Okay, I want to compare the first and the last one really quick. Okay, so notice the difference, okay, between inequality symbols where we just have a less than, okay, versus inequality symbols where we have the less than or greater than. The less than or equal to. Okay, so again, these have the lines underneath these inequalities down in the bottom example. So that means that we can equal -2 and we can equal 7. Okay, versus the top one, we don't have the or equal to symbols. So that means I'm going to get really close to -2. I'm going to get really close to 7, but I'm never going to actually equal those values. So the way we can represent this on a number line is if we equal the value, okay, we used a closed circle at that value on the number line versus an open circle, okay, when I don't equal the value. Okay. And then the way I would, again, finish this on the number line is I would shade the portion between -2 and 7, okay, because again, I'm looking at all the values that are greater than -2 but less than 7. Okay, so the way we represent this using interval notation, okay, is notice we have between negative, we go from -2 to 7. Okay, so we read things from left to right when doing my interval notation. Okay, the only difference between the top and bottom examples is the punctuation that we use. Okay, so if we equal a value, we use brackets. Okay, versus if we get close to that value but we don't actually equal it, we use a parentheses. Okay, so that is the big difference between, okay, these two. So again, the or equal to means I use, you can't really see the colors because those are shaded yellow. Okay, the or equal to means I use the brackets in my interval notation, okay, versus parentheses, okay, when I'm close but not actually ever going to be equal to 7. I'm just less than 7. Okay, so this is my interval notation, and again, I go left to right to match the number line. Okay, so we can also notice these examples, okay, had the same inequality symbols. Okay, we can also do one where we have a combo of the inequality symbols. So we are less than 7, but we are greater than or equal to -2. Okay, so the way we would draw that is we'd have a closed circle at 2, we'd have an open circle at 7, okay, and we would still shade everything in between. Because this is saying I'm going from, the way I can read this is I'm going from -2 to 7 on my number line. Okay, I'm shading everything in between. So all the values between -2 and 7 are possible answers to this problem. Okay, I'm just including -2 and I'm excluding 7 from that shading. Okay, so that is some examples where I'm looking between two numbers. So now let's look at some examples where we're going to infinity and negative infinity. So negative infinity, okay, is represented by the left arrow of our number line. Okay, positive infinity is represented by the right arrow on our number line. okay? Infinity, guys, is a concept of a number, okay? It's not a specific value, okay? Because any like massive number you tell me, okay, I can just add 1 to it, okay? Or I could add 100 to it, or I could add 1,000,000 to it, all right? So any number you tell me, I can add more to it. So I could just continually keep getting larger and larger and larger. So again, it's not a specific value. It's the concept of the value, okay? So when I do these problems, okay, let's say 9 is here. So if I look at this first one, I have x is less than 9, okay? So if I'm less than 9, I'm going this way on my number line, okay? And I have all of these values that are less than 9. Okay. So if I think about it in terms of my interval notation, if I go left to right, okay, I'm going from -infinity to 9. Okay. And again, this is a less than, okay, it doesn't have an or equal to, so it gets a parentheses. Okay, that means it also gets an open circle. And then, guys, infinity and -infinity are always going to have parentheses. Okay, so this also gets a parentheses, okay, because again, it's not a specific value. I don't have a number value for -infinity, okay? So because of that, we just do a parentheses. So that is an example where I'm dealing with -infinity. Okay, so now let's look at one with infinity. Okay, and notice this is a greater than or equal to, so it has a bracket. Okay, so if I think about my number line, okay, I have a closed dot at 4, and then I'm greater than 4. So any number greater than 4 is going to be the numbers on this side of my number line. So I'm going up to infinity. Okay, and so that is my interval notation from left to right. And just so you guys know, when doing these problems, okay, a lot of the time, when I do them, I'll start with my inequality symbol, and then I think it's easiest to go to the number line, and then I think it's easiest to go to the interval notation, okay? So that's kind of the process that I found be most helpful for students, okay? If they have to do the final answer in interval notation, they take the inequality symbol, they think about what that looks like on a number line, and then they convert that to interval notation. Because once you have your number line, again, you just got to go left to right of your shaded portion, okay? And that becomes your interval notation. Okay, let's look at this last one, okay? Notice we've got 2 parts, okay? So we've got x is less than 1, okay, and greater than 5. So we've got parentheses for both, okay? Again, I've got a -infinity, so that also gets parentheses. Okay, I'm going to go ahead and plot these points. So we'll say 1 is about here. We'll say 5 is about here. Okay, both get an open circle. Okay, and what this looks like is x is less than 1. So if I'm less than 1, I'm anything that is smaller than 1. So it's all of these values going down to -infinity. Okay, and if I'm greater than 5, I'm everything to the right of 5. Okay, up to positive infinity. And then again, I can just read my number line from left to write my interval notation. Okay, so I start at -infinity, and then I get to 1. Okay, and then I go on to 5, and then I have infinity. Okay, now notice, let me use a different color. We'll use gray. So notice this U, that represents that we have this kind of jump, okay, this space in my number line where I don't have possible values as my solution, right? So anything between 1 and 5, okay, so like say 2, it is not less than 1 or greater than 5, okay? So it's not a possible solution. Okay, so anytime I have a U, that represents that kind of like gap in my number line where I don't exist. Okay, you can also U. This is called a union. This is the symbol for union. Okay, you can think of this as an and. Okay, so you literally can just think about this as anything less than 1 and greater than 5 is our set of possible solutions. Okay, so I'm sorry. I said that wrong. I knew that was wrong as soon as I said it. I was trying to figure out what I was messing up. It's an or. My bad. Okay, so notice it literally says or right here. Okay, so it's like saying anything, any possible numbers less than 1 or greater than 5 are my set of possible answers. Okay, that sounds better. Sorry for that mix up. Back to the interval notation. Okay. And I know it looks way more complicated than the other ones we've done so far, but just remember, if you think of left to right on your number line, that's left to right in your interval notation. You know that you've got parentheses everywhere because you've got a parentheses always for negative infinity and infinity. We've got open circles, so that means parentheses. And again, we've got that gap, so that means we have a union. Okay, because that means we've got this piece and this piece. Okay, so that union again just represents we have multiple pieces being combined to give us our set of possible answers. And that is interval notation. Okay, so I want you guys, for your practice, okay, for this lesson, okay, you guys are going to do a quizzes. So go to joinmyquiz.com, type in this code, and then it should come up. If you have any problems accessing it, please let me know. This is going to be your lecture kind of grade for today. It's completion based, so if you get one wrong, don't worry. I think it gives you multiple tries too in quizzes. So let me know if you have any questions or any issues getting access to this.